Okay, so good morning, everyone, and welcome to the introductory session for this program that we are going to start. This is the 3.5 months full-time online structural engineering training program, and we are going to learn hands-on structural engineering by working on actual steel projects. So this is the program that we are going to start very soon. And this is the introductory session for the same that we are conducting. So before I begin, I hope I am visible and audible to all of you. Am I audible to all of you? You can just, yeah, so all of you are on mute right now. So the only way for you to communicate with us is by typing in the chat box. So I hope I am audible, I am visible, and you can see the presentation also. All these three things are, uh, you can see the presentation, you can hear me, and you can see me also, correct? Yes, all okay, good. So let's go ahead then. Once again, welcome to those who are joining, and many of you are joining on YouTube. Many of you would be watching this session later on YouTube. So we welcome to all of you. So what is going to be the agenda for the day for today's session? So I'll be just presenting for around 45 minutes, and then we can have all your queries. Okay. So the agenda would be, let us first understand why are the structural engineers not confident of steel design. Then we will talk about the need for this program. Then a few things about us at AuxEn and KCPL. Then how we have evolved over the past 5-6 years. I'll just take you through the evolution process. Then a few things about us, the details of this program, what are going to be the features of this program, the program fee and other details, what is the expected outcome, how to proceed ahead, and queries if any. So this is going to be the agenda for next 45-50 minutes. If you have queries, you can ask your queries at the end. If you want to ask your queries during the session, you can just type in the chat box, and if the query is relevant, we will take it then and there, or else we will take it at the end. So very pertinent question, why are structural engineers not confident of steel design? So as a structural engineers, I think you must have felt this, that there is lack of confidence structural engineers have when it comes to steel design. Even for practicing engineers, even for working professionals, this is true. Even for those who have been working for many years, they seem to be not very confident when it comes to steel design, and it is always a hitch that they have in doing steel projects. So these are our thoughts why we feel structural engineers are not confident. So I think the problem starts at the undergraduate or postgraduate level, where the subject to our mind is not properly taught. The books, there are some excellent books that you have on steel design, steel structural details, designs, but they mainly focus on the theoretical aspects. So the structural engineer is not able to get a sense of how to do the actual steel projects. Okay, so we may know the theoretical aspects, but we may not be very good at the actual process of doing projects. Why? Because there is no proper document, there are no proper books which cover these issues. Then, as most of the design firms, structural engineering firms, are only doing RCC projects, what happens is that the structural engineer is not able to learn structural design on the job, isn't it? A large part of our learning as an engineer, as a working professional, comes on the job, when we learn on the job. But because not many companies are doing steel projects, most of them are doing RCC projects, so the engineer is not able to learn structural steel design on the job. That is another problem. And therefore, what has happened today, what is the scenario these days, is that we have to rely on some third party, or we have to rely on some external company to do the steel designs for us. So if you have heard about pre-engineered buildings. I hope you have heard about pre-engineered buildings. So these days, most of the steel projects are being done as pre-engineered structural buildings or pre-engineered projects. So what happens? You just give your work to some third-party external company, for example, to a company like Kirby or InterArch or Tata BlueScope, or there are several pre-engineered companies, pre-engineering companies. So you just give your work to these companies, and you just do the RCC footing or some RCC supporting design for the project. All right. So this is the current trend that you see, that the steel design projects are outsourced because we do not know how to design and we are not able to learn them on the job. So these are some of the issues we just wanted to highlight, and these are few of the reasons we feel why structural engineers are not confident of steel design. Then why are we doing such a hands-on program? So we feel that we learn by self-realization. How do we learn? The best process to learn is to do something hands-on. So when we do something hands-on, we learn in a proper and a better way, long-lasting way. But how to get hands-on work? So one can only get hands-on work when we are either employed or working on some real-life projects. So this is an intriguing, I would say, situation, that the employment or some sort of self-practice is essential for gaining experience, but no one is ready to give you employment until you have experience, isn't it? So this is a perfect catch-22 situation that you face. Everyone faces the similar situation. So we at AuxEn understand this, and therefore we have introduced this program under the Structural Design Center. So the program that we are introducing through these 3.5 months, we are going to design 4 structural steel projects, and we would be doing these projects right from the initial planning to the final drawing development, BOQ preparation, and design calculation preparation. So I told you there were 2 problems. First problem was that structural engineers generally are not good at steel design. And the second problem was that we do not have the required experience of working on actual projects. So through this program, we are addressing both these issues. First, this program will be covering actual 4 steel projects. So we would be taking the participants on a journey of these 4 projects, and from initial planning to final BOQ and drawing preparation. So through this program, we intend to address both those issues that I just highlighted. So we will try to create a working environment for the participant as they would get in a real life design consultancy firm. And we would try to give the participant some realistic experience of working on steel projects. We would try to make the participants understand the roles and responsibilities of a working structural engineer. So all these things we intend to do through this program. So as I said, therefore, the need of this program, our intention is to prepare the participants to work as an independent structural engineer if they wish to do so, or to enable them to join any professional structural design firm. That is what we intend to do for our participants. Okay. I will be talking more on the projects that we are going to take in this program. But before that, a few things about AuxEn, that is the firm, our firm that through which we are organizing this program, and our structural design firm. So our firm is, the parent design firm is Kutumble Consultants and Engineers, and we are involved in doing different multidisciplinary structural engineering works. We do a lot of industrial designs, infrastructural projects. We do commercial and residential projects. Warehousing and logistics is another vertical where we do the projects. We work a lot on design development, designing new systems, developing, I would say, mainly in steel designs, developing new profiles, developing new systems, working on some theoretical aspects. So a lot of design development work also we do apart from your usual project. That is, we do projects which involve peer review and third party consultation, or as a third party expert. Repair and retrofitting works also we do, and a lot of forensic engineering works we have done. So you will see that all the multidisciplinary verticals of structural engineering we are doing the works in. And then in addition to this, since 2015, uh, myself and my wife Akanksha, both of us have been involved in this training and skill development firm. So earlier we started with taking offline sessions. We used to conduct offline sessions in our office where the structural engineers and participants used to join for our programs. And then uh, after the pandemic, we have completely moved to online. So that is how we have been doing since 2015. These are some of the projects that we have undertaken under our design firm. So this is a steel grain storage system that you see on your left. This is another project that we did for a cement plant, another cement plant photo, a residential construction. So most of these are industrial structures. If you see some of the bridge projects that we have done, all these are steel pedestrian bridges. So this is a bridge at Haridwar. If you have been to Haridwar, you will see this. This is called the Shiv Dhanush Bridge that you can see. This is a long shot photo. You can see the entire city of Haridwar, not the entire city. You can see the Ganga Ghats over here and the Shiv Dhanush Bridge that we have done. Some other images of the same bridge at night, and the sectional view. And this bridge is regularly featured on the Uttarakhand government's portals, on the Uttar Pradesh government portal, and it's quite a popular destination. In the Kumbh Mela that was recently conducted, it got a lot of media attention, this bridge. So we did this bridge in 2016. This is a completely steel pedestrian bridge. Then some of the bridges that we are proposing right now, all these are under proposal stage. This is one of the bridge that we have proposed at Badwa, Madhya Pradesh, on the river Narmada. Another bridge that we have proposed on the river Narmada again at Omkareshwar, Madhya Pradesh. So these are some of the projects, and you will see these are glimpses of some of the sessions that we have conducted offline. So before pandemic, we used to conduct offline sessions. These are some of the glimpses of it. Again, some lectures, technical presentations that we give on the engineers forum. You will see some images. So till now we have conducted 18 online courses. And if you see, all our 18 online courses are on different topics. They cover in-depth structural subjects, and we try to go in a lot of details with detailed manual calculations and with software verification, working on software. So we try to do all these things in our online courses. We have had a great experience of conducting online courses till now, and our participants usually are from all across the country, and outside India, from the Indian subcontinent, from Middle Eastern, Western African countries, from South African, and even from Eastern European countries. Participants have been attending our online courses. So this is the great benefit of conducting courses online, that we get a great geographical reach. In almost all our courses, our participants are a good mix, I will say, of graduate, postgraduate students, research scholars, practicing professionals, working consultants, faculty members. So always there is a good mix which ensures good peer-to-peer learning amongst the participants. And we feel overwhelmed by the response that our participants show, and the love and affection they show towards us. And therefore we feel very enthusiastic about conducting better and bigger programs. So how we have evolved over the past 4-5 years. So we have realized that as a structural engineers, we need two things. So we need strong theoretical base with software proficiency. So as a structural engineer, you should have a very good theoretical base. You should understand the theory. You should understand the standards. You should understand the Indian standards, the American standards, whatever. You should have great theoretical knowledge. Plus, you should also have software proficiency. So in today's day and age, it is extremely essential that you have a good working command of softwares. So you should have a good working knowledge of STAD, ETABS, uh, I would say SAFE, then AutoCAD. All these softwares are very important if you want to work as a structural engineer. I would say MS Excel. So you should have a strong theoretical base and you should have a good software proficiency. When I say software proficiency, it's not only about uh, knowing how the software works, but you should have a working knowledge of the software. What are the glitches? What are the shortcomings? How much or what you can achieve on a software? All those things also you should understand. And of course, you should be able to work on a software with good speed. That is also essential. So this is important, but this is only the first part. In addition to this, what you further require is the actual experience of doing projects. Okay. So this is again a very important second aspect of a good structural engineer. So having strong theoretical base with software proficiency is first, but you should at the end of the day also have experience of doing actual projects. So how do we highlight this? How do we highlight these two things? So now we are working on a two-pronged strategy for building a strong theoretical base. We at AuxEn, what we do to build a strong theoretical base with good software proficiency, we have self-paced courses. So we have around 10 self-paced courses which focus on building a strong theoretical base along with working knowledge of softwares and proper understanding of Indian standards. To address the second issue, that is to have experience of working on actual projects, we have started with the structural design center programs. So what you are attending is one such program, the second program in the series, that is aimed at gaining, or that is aimed at imparting experience of doing actual projects. So one program on RCC projects is ongoing. We are as I speak, we are conducting an online program where we are discussing how to do actual projects, RCC projects. So we have taken 4 RCC projects and we are doing that. That program is online right now. Online means that is ongoing right now as we speak. And in this same series, we are going to start the second program under the Structural Design Center, which you are attending the introductory session of, and it will be on actual steel projects. So that is how we have evolved over the past 5 to 6 years, and we are addressing both these issues by 2 different solutions. So one is the self-paced courses to build a strong theoretical base, and the other is conducting structural design center programs for imparting experience of working on actual projects. All right, good. Then before I move to the details about the program, a few things about us. So this is me, Ashutosh Kutumble. You can see me on screen. So I have done my BE from SGSITS Indore and MTech from IIT Roorkee in building technology. So after that, I worked for 2.5 years in a multinational consultancy firm, Dar Al Handasa. And since 2014, I have been involved in working in our firm and also involved in conducting trainings. So it has been a long journey till now. And on your left, you can see my wife, Akanksha. She has done her engineering from Engineering College, Kota, and MTech from IIT Roorkee in building technology. She has 12 years of experience. She worked in ACOM after her MTech, and then she has been involved as a faculty at various positions in different colleges. She has also worked in Dar Al Andasa for 2 years, and since 2014 we have been working together. We have been conducting trainings, working on design projects. So it has been a long journey. And yes, we were classmates at IIT Roorkee, so that's how we met and got married. Anyway, so now we come to the main aspects about the program. So just pay attention to this section, because we are here going to discuss whatever is going to happen in the program. All right. So let's see details. So first of all, I have put it in red. Remember, this is not a program aimed at spoon feeding, but we expect that you try to learn through hands-on approach. So we expect that the participants devote considerable time towards this program. Only when you devote time, only when you do the dirty work, only when you spend a lot of hours will you learn hands-on. Okay. So in this 3.5 months duration, we are going to take 4 projects, 4 structural steel projects, and yeah, so the projects will include, now you will see a list of the projects. The first project that we will be doing will be a pedestrian footover bridge. This we will be doing using StatPro. Then we will be doing an industrial steel structure. We will be doing a PEB warehouse shed. And the fourth will be a big hospital building. So you will see that through these 4 projects, we are trying to cover different possibilities of steel structural designs. Okay. So deliberately, we have chosen these 4 different projects through which we would be trying to address different issues involved in structural steel design. And we would be trying to cover most of the most structural types that are adopted in structural steel projects. Okay. So one is an infrastructural project, the footover bridge. The second is an industrial structure. The third, you can say, is a warehouse and logistic structure. And the fourth is an institutional building. So there is a great diversity in these projects that we will be having. Now I will just take you through the details of these projects one by one. So let us have a look at all these projects. But before we move ahead, I would like to tell over here that all these are actual projects. These are not dummy projects. Dummy project by I mean that these are not projects of my imagination, or these are not projects which I have just created to be discussed in this online program, but these are actual projects. All the projects have been executed, and because these projects are big scale, I would say they proudly tell the tale of what we as structural engineers can achieve. Why actual projects? Because actual projects bring real life challenges. Okay, when the project is a dummy project, I can always work my way around. I can always make it simple so that I do not have to enter into complexities. But when we do actual projects, they bring actual challenges, real challenges. We face real difficulties. Your design process will not be streamlined, because in books or in classrooms, we see a streamlined process for everything. But you know that in real life, there is nothing like a streamlined process, isn't it? Everything is chaotic. So when we do actual projects, there's going to be a lot of chaos. There are going to be a lot of problems. There are going to be a lot of challenges, a lot of things where our Indian standards will not work. A lot of times we will have to do jugaad, as we say in Hindi. So all these real challenges one faces when we do real projects or actual projects. Many of you must be working somewhere as engineers, structural engineers. So I think you will appreciate that in your offices, you face this situation, isn't it? That things do not go well when you are doing actual projects. So therefore, the reason that we take actual projects to face real difficulties. Only when we face uncomfortable situations is when we learn out of it. And I would say we also face uncomfortable situations. So it's not as if we are not facing uncomfortable situations when we do projects. Everyone faces difficulties and difficult scenarios. So that's why we have taken all these projects, which are actual projects. As a add-on, what we are going to do is that two of the projects we will be designing using ETABS, and two of the projects we will be designing using StatPro. How many of you have heard this, that StatPro for steel design and RCC should be done on ETABS? How many of you have heard this, that for steel design use StatPro, and for RCC design use ETABS? We often hear this, isn't it? So we will be trying to break that myth, and therefore we will be doing two projects on ETABS and two projects on STAT. All right, so that will give us a complete picture. So let us now look at all these projects one by one. Am I audible till now? Is everything going good? Hello? Is everything okay? Yes, good. So let us delve deep into all these projects one by one. So the first project that we are going to take is a pedestrian footover bridge. So what are going to be the features? So this is a system that you frequently see in the urban spaces in almost all the cities of our country, and outside also you see pedestrian footover bridge, isn't it? So this is a frequently used topology that you find in urban space. The total length for this bridge is 130 meters with central spans of 45 meters. We will be doing this project using StatPro. So this is the plan of that. It is so big that I am unable to fit it in this slide, but I think you can make out this is the plan view. Can you see this? I am marking red lines on the, I'll use a different color to highlight. So I'm putting it in blue. I hope you can see. So this is your footover bridge in plan. Hello. Something like this. This is the plan view, and this is the traffic flow. So this is the traffic flow. Okay, whatever. No, our in India, traffic flows in the opposite side, isn't it? I should not have marked like this. This is the traffic flow. Yes, this is the traffic flow. And this is a central road, big rotary. This is in, this was done in actual city of Madhya Pradesh. And you can see this type of footover bridge was planned to basically help the pedestrians to cross this big rotary, because this is a very, very big circle. So zebra crossings will not, there are zebra crossings, but an effective solution was needed, for which this type of pedestrian footover bridge was planned. Are you able to listen to my voice? Because Mr. Sandeep is saying he is not able to listen to my voice. I hope my voice is audible. Yes. So Sandeep, just check if you have logged into the audio or not. All right. So these are going to be the trestles. These are going to be the trestles, or you can say the vertical elements. And these blue lines are going to be the pedestrian footover bridge. So the plan is that a person should be able to walk from here and should be able to cross to this side. Okay, so this will be our first project. This is the plan view, and I will now show you the view of this developed elevation view from this side. So let us look at this view. This is the developed elevation that you see. Okay, these are your trestles on which, because the direction of bridge is changing, you have to provide some vertical support. And this is your pedestrian footover bridge over here. So person is supposed to walk here. So whoever is walking, they are going to walk on this plane. Clear? And then there are staircases to climb down. So this is going to be our first project. Many of you must have seen such type of systems in your cities or towns, wherever you live. So this is a commonly used topology, commonly used structural system. And these spans, central spans, are going to be around 45 meters. Okay. And the total length, because this is the developed elevation, the total straight line length would be around 130 meters with supports. So this is going to be our first project. We'll be doing it in StatPro. And through this project, what do we intend to learn, what should be our key learnings. So first thing that we would try to learn the use of hollow sections, rectangular hollow or square hollow sections, or built up sections in this project, because in most of these bridge type systems we prefer to use hollow sections because they aesthetically look good, or built up sections, built up angles, built up channels, those sorts of sections. So we would try to learn the use of these sections in projects. We will try to throw some light on IRC6. We would try to learn IRC6, not in great detail, but few points of IRC6, and IRC SP56, that is a special publication for steel pedestrian bridges. Okay, so these two things we would try to learn. Of course, we will be learning how to apply wind loads and moving loads in STAD. So STAD has a good option to apply moving loads. We will be doing that also. Then understanding the design and detailing of a trussed bridge system. So bridge systems are usually truss systems. We'll try to learn that also in this first project. We will be doing this entirely on STAD Pro. So through STAD, how to do the design and detailing, we will learn that also. You will not see connection design over here, but we will be doing all sorts of connections. So connection design that we will be doing the connection design using manual methods, using some MS Excel spreadsheets, and we will be also doing the connection design on a very good software that we will be using for the first time, that is called as Idea Statica connections. How many of you have heard about Idea Statica? I think few of you must have heard about Idea Statica connections. So it's a very efficient and a very good solution to do the connection designs. So we will also be doing connections using this software. Okay, so this is how we would be doing our connections. Then yes, then the second project that we will be doing is, it's going to be a massive industrial steel structure. Why I'm saying it's massive? Because it is very large plan. 20 meters by 39.5 meters is the plan, and 60 meters is the height. So 60 meters is almost it's almost 20-story building, isn't it? So we are together going to almost design and detail a 20-story structure. So 60 meter is huge. So it's a massive structure, subjected to heavy grade industrial loads. So nothing will be small in this. Okay, everything will be big, everything will be huge in this industrial steel project. Heavy loads, heavy sections, everything will be giant sized. We will be doing this project on ETABS. So deliberately we are choosing this to do on ETABS because of some, I would say, some benefits that you get when you use ETABS. So we'll be doing this project completely on ETABS. Then, so this is the sectional elevations. You can see we are unable to fit it on this slide. It's so big. So this height is 60 meters. This is 60 meter height. And you will see different levels, different loadings, different equipments. Okay, all these equipments you can see. And I think in none of the programs I have seen they do any sort of industrial structures. No one does that. So we will be doing it in this program. What are the expected key learnings? So these are the two sectional elevations. This is the plan view. Just for representation purpose, actually there are several plans, but I could only show two plans in the slide right now. What are the expected key learnings? One very important learning is how to read and understand the industrial general arrangement drawings. Okay, so that is itself a skill that structural engineers need to acquire if you want to do industrial structures. How to understand and read general arrangement drawings, how to apply wind and seismic loads, because this is quite a tall structure. Wind loads, seismic loads will be governing or critical. Seismic load will be governing because of heavy masses that are there on this structure. We would be applying IS 1893. Which part for industrial structure? which is the part for industrial structure. So we would be also having a look at IS 1893 part. Hello, which part? Part 4. Yeah, so part 4 for industrial structures, we would also be going through it if we want to apply seismic loads. So these are the expected key learnings. Plus, this structure will be designed as a moment frame system with use of some bracings. So through this project, we will understand the design and detailing of a moment frame system. Mainly the sections involved would be plate sections, 3 plate sections. 3 plate section means plate girder. So there will be 1 flange, 1 web and flange. So we would be designing and understanding the process of doing 3 plate sections. Okay, mainly the sections will be built up plate sections. So through this project, we will learn the design and detailing of plate sections using ETABS. As I explained, we would be using ETABS for this project. Then the third project will be a big warehouse shed. Pre-engineered warehouse shed is what we will be doing next. Again, this is quite a big project, 55 meters in width. This is the plan size. So the plan size is 55 meters. So the span, the width is 55 and the total length is 101 meters. So we will be having in PB systems, in PB sheds, we have our portal frames. So portal frames we will be having placed in this direction. Clear? This is how the system will look like. And the eaves height will be 10 meters. What is the eaves height? Means if this is my, of course, this is not to scale. Let me just try to draw it to scale. If this is my 55 meters, then this eaves height will be 10 meters. So this is how our system will work. Because it is an internal, because this is a big span, 55 meter span, we will be having internal columns. Okay. So these magenta colored boxes show you the position of internal columns. Can you see it on the screen? What I am drawing right now? Hello. Is it visible? Okay. So these will be having internal columns, but the internal columns will be provided on the alternate frames. So every alternate frame, we will be providing an internal column. Okay. Why so? Because we want to have a clear space inside. Nobody wants to have closely spaced internal columns. So the internal columns that I'm drawing in green are provided on alternate frames. Can you see this? So what do we do where we are not providing internal columns? So we support it on a system which is called as jack beam. Why I'm telling you all this is because I have mentioned jack beam. So therefore I thought I'll just tell you jack beam. So this is my jack beam. What is jack beam? Jack beam is, you can say, a secondary beam that we have provided to support the frame. Okay. So here where I don't have a internal column, I am supporting this frame. I'm supporting this frame on my jack beam. Okay. And jack beam in elevation will be provided at the ridge level. So this is called jack beam. This is a system which is often used in your PB sheds where you do not want to have columns. So through this project, we will be also learning the use of jack beams. This in itself is quite complicated. Okay. This system in itself becomes quite complicated. And if you see the spans, they are quite large. So this is again a big project. So this is the feature. The intermediate column spacing of 15.6, as I just explained, every alternate bay you will be having an internal column and it will be having jack beams. And we will be doing this project on StatPro. So these are the features. This is the plan view that you can see, 101 meter length, 55 meter width. Again, it was so big that I could not fit it in this slideshow. And this is what you see as the elevation. This was what I was telling you right now. So this is my jack beam that I have provided to support the frame where I do not have internal columns. So every alternate frame will look like this, and every alternate frame will have an internal supporting column. So this is going to be the scenario, or this is going to be the structural configuration. So this is our third project. What do we intend to learn? The first thing that we want to learn is to understand the pre-engineered shed systems. What are the different PV systems that we should know and we should be able to design? How to apply wind and seismic loads on these. Wind load will be governing in this case, seismic not so much. And of course, because this is a pre-engineered system, mainly we would be using plate sections. These days, if you see in steel structural projects, most of the sections that are being used are plate sections. Why we are using plate sections these days? Because of the ease of using plate sections, because of the ease of fabrication, because of the ease of erection and connection. So most of the sections that you see these days are being used. The most commonly used sections these days are plate sections. So this PV project warehouse building we would be doing using plate sections, because that is what people use in pre-engineered systems, and we would be doing this project using StatPro. So it will teach us to do these types of projects in StatPro, using StatPro. Good. And the fourth project is an hospital building. This is a uniquely shaped G+2 building having a big area, 198,750 square feet total area. Total G+2 area is this much. Again, this will be done and executed, because in actual also it was executed as a pre-engineered system. So the design was done, and then the execution part was given to a pre-engineering company. So we will be doing this project by using the same sort of sections. This project was actually, this is an actual project, not of us, but of Skeleton Consultants Private Limited, NCR. So we have taken permission from them, and we would like to express our gratitude to Skeleton Consultants, Engineer Abhay Gupta sir, who is the director of Skeleton Consultants. I think you must have heard about him. He is a big name when it comes to structural engineering, and he is an authority in wind engineering. So he was our professor at college. So he was kind enough to allow us to use this project for this program. As I told you, this is a uniquely shaped building. You can see the plan view. So this was actually, yeah, I will tell more about the shape in the program, but you can make out that this is a uniquely shaped structure, isn't it? These are the plan views. This is G+2. So this is ground floor, first floor, second floor. Remember, this is an hospital building, G+2 structure. So this is what we would be doing in the fourth project. What do we want to learn? So because in this project, architectural constraints, there would be a lot of architectural constraints. So we would be learning how to prepare framing plans based on the aesthetic and architectural requirements. Then, of course, wind and seismic. But again, in this case, wind will not be so much governing because of the short height. So seismic might be more governing. We would be doing plate sections once again in this, but this time we would be using ETABS. So these are the expected learnings of this project. So these are the 4 projects that we have selected for this. Once again, I'm repeating, but you will see that all those projects are quite big. They are quite huge and quite challenging also. None of them is going to be simple. So they are going to be quite challenging. Then for each of the project, we'll be following this step-by-step approach as we do in some real structural firm also. So this is how your projects are done in any office, in any design center by any consultant. These are the step-by-step approach we follow, starting from initial planning, load calculation, then modeling on any software, then the design and detail and analysis. And because it is steel construction, we need to do the connections also. So each and every connection, either you do through some manual methods, or you use some developed Excel sheets, spreadsheets, or use some software. So we will also be using some software to do our connections. So this is the step-by-step approach we would be following. And then we will also introduce you to the drawing development using AutoCAD. We will not be doing the actual drawing work, because in steel design, the actual drawing work is slightly more complicated than your RCC. So we will not be doing your actual drawing work, but we will be introducing you to the drawing development. So what we are expecting is that if you work as a structural engineer, you will hire someone who will do the drawing work for you. You will hire some draftsperson, or if you are working in some big company, there would always be some draftsperson working for you. So we would not be developing, or we will not be making the drawings ourselves, but we will give you the introduction to drawing development. That means you should understand how the drawings are to be developed, even if you do not know, or even if you are not able to do the actual drafting work yourself. Okay. So drawing development, introduction to it will be given. Then BOQ preparation. Preparation of BOQ in steel is quite simple. It's not as complicated as you find in RCC, because in RCC projects, there are a lot of items that you have to keep in mind when it comes to preparing BOQs. But in steel design, the BOQ preparation is simple. Then we will also understand how to prepare design calculation reports, because as structural engineers, you are required to submit calculation reports also. And plus, one more important point that I would like to highlight over you. So in this program, mainly we are doing actual projects, isn't it? In this program, we are mainly focusing on the actual projects, or how to do actual projects. But if you want to have some theoretical base, because I explained that as structural engineer, you require good theoretical base and software knowledge, plus the experience of doing actual projects. So actual projects are being done in this program, but to have a theoretical base for it, to have a background knowledge for it, what we are doing is that we are introducing and adding 2 online courses that we have conducted in the past in this program itself. So these 2 online courses that we have conducted, one is a detailed course on structural steel design and detailing. So it was a comprehensive course, 48 sessions, 96 hours that we have conducted in the past, covering the entire structural steel design through manual calculations, through codal provisions, everything we have done in this. So this will form the theoretical base for you. Okay. Because when you start doing an actual project, you will need some theoretical base. So this course will form the theoretical base for you. So this is the first course which will be part of your package. This has been conducted earlier, but it will be added to your package so that you can refer to these courses whenever you need some theoretical understandings. And the second course that will be added to your package will be another online course that we had conducted, design and detailing of pre-engineered systems. This was again a comprehensive course, 34 sessions, 68 hours. So these two courses, online courses, will form the theoretical base. So suppose I want to tell you some point. Let's say I want to tell you about some compression member design. So because we are involved in doing actual projects, what I will do is I will just tell you that watch session number so and so of this online course. Okay. So that's how you will get theoretical understanding. In your actual office also, if you work in some office, nobody, your senior does not make you sit and teach, isn't it? What they tell, that refer to this book, refer to this document, isn't it? So similarly, we will be telling you to refer to these online courses that we have conducted. This will enable us to save time and concentrate or focus on doing the actual projects. All right. So for theoretical base, these courses are there. These will be added, and we are doing the actual projects in our program. Hope you get it. So this is how each project we will be using a step-by-step approach. We will be, yeah, someone had asked. So daily we will be having one session, morning session, 8:30 to around 10:15. Sometimes it goes to 10:30. Sometimes we finish it at 10 a.m. So this will be an important session in the morning where we will be discussing mainly what needs to be done in the project. So let's say we are starting with first project. So we would be discussing about the project, what needs to be done, what are the tasks that you need to do. Then between the 10:30 to 3:30, you can work on your own. So if we have given some task, you are supposed to do that, or you spend some time with the project, whatever you want to do, it's your own time. And then again at 3:30 in the afternoon, we will have a second session where we will just discuss on whatever has been done during the day. And if some extra information or additional information has to be given, it would be given during this time. So we are looking at 80 work days. So one such day will comprise these things. This is one such working day, and we are looking at 80 work days, around 3.5 months of time. We conduct Monday to Friday. Saturday, Sunday are for you to relax and to reflect back upon the week. So all sessions we will be conducting on Zoom. Right now, the mode that you are attending, if you are not attending on YouTube, that is, we will be having regular one-on-one interactions where we will be interacting with the participants. We'll try to understand their queries to see what doubts and challenges they are facing. So we'll try to have this on a regular basis, one-to-one interaction. We'll try to monitor the allotted work, whatever we have given. We will ask you to submit us, to send us on mail, and then we will try to see how you are doing. Then we'll try to conduct quizzes after completion of each project. If we are not doing after each project, at the end we will surely conduct a question answer quiz on what you have learned during the project. Then, as I told you, you will be given access to 2 online courses conducted by us, which is steel design and detailing and the PEB systems design and detailing, which will form the theoretical base for this program. And then all the recorded sessions for this program will be available for a period of 1 year. So every session will be recorded and uploaded on the portal, and it will be there for you to review and revise for a period of 1 year. Then now who can join this program? So we are looking at BE or BTech civil engineers. If you have done post-graduation, that will be even better. But we are not going to have any person who is pursuing engineering. So you must be at least BE or BTech in civil engineering. Then if you are a graduate, it's even better. ME, MTech, structural engineers, those structural engineers who are looking to join some design firm, or many of you are wanting to start as consultants, then this program is best suited for you. If you are a recent structural engineer and want to gain more experience and want to build up, then you are welcome. Experienced civil engineers who want to switch and who want to start working as structural engineers, they can also join. And of course, working professionals and practicing consultants who are looking for steel design experience, so they can also join this program. We are looking at 25 to 30 people. That's the max we can manage. And if required, we may conduct some interview just to understand if you are a good fit for this program. Before I move ahead, many of you have asked, therefore this slide. So if you are a working professional, then how can you join this program? Because clearly the timings might not be suitable for you if you are a working professional. So how you can join? So we have the option of joining as self-paced learning program. This means that you can take out time as per your own convenience, and you can watch all the sessions online. Every session will be uploaded online within couple of hours of conducting. Those sessions are available on our portal, so you can watch those sessions online as per your own convenience. This is, I'm talking about the working professionals or practicing engineers who want to join and who are not able to take out time. The task that we are giving, the working professionals who want to join, they will have to complete the task as per their time schedule. And for them, for the working professionals or for practicing consultants, we would be organizing periodic discussions, and we would be organizing periodic interactions, mostly during weekends, so that they can take out time and interact with us. So this is the scheme that we have for working professionals. And of course, all the sessions will be available for a period of 1 year. So you will get ample time to go through them. Okay. Then what is the program fees? So the program, the entire program, all the 3.5 months with all the inclusions, etc. The total cost would be 45,000 rupees. For the first time, we are giving some discounts to our participants who have joined our previous courses. This might look a little bit complicated because the language is slightly complicated. So just throw more light on it. So those participants who have done steel design course with us in the past, they will get a discount of 2500 rupees. Those participants who have done PEB design course with us in the past, they will get a discount of 2000. If someone has done both these courses, then the discount will be cumulative. That means 4500 will be the discount. And if someone has done SDC1 program with us, the program on Structural Design Center program on RCC projects, if someone has done that program with us, then they will get discount of 4000. So all these discounts are cumulative. That means a participant who has done all these three stands to get a total discount of how much? They stand to get a total discount of 8500. Okay. This is looking like some Indian standard clause, isn't it? The language makes it complicated, but I hope you get it. So all the discounts will be cumulative depending on whatever courses you have done with us in the past. You can pay the fee as lump sum, that means in one go, or you may pay the fee in installments. So the first installment you can pay at the time of joining, and the second installment you can pay after 1 month of completion. What does this course fee include? So this course fee or program fee includes all the sessions with all the deliverables, everything for a period of 1 year that you can watch online. It includes, as I have repeated, it includes 2 online courses that we have conducted. So these 2 online courses will be a part of your program. If you try to take them separately, they cost you around 9,000 rupees. So that is also included with the program fee. And of course, it includes lifetime association with us at AuxEn and other like-minded individuals. Now, what will be the return on your investment? You will notice that we are not calling it as a expenditure. We are calling it as an investment. Of course, you would be interested in knowing that what will be the returns on the amount that you are paying. So if you do this program and suppose you join somewhere, maybe the program fee will be around 1 month of your salary, isn't it? If you are able to join some firm, or if you if you join some firm, if you clear their interviews, if you associate with them as a structural engineer, then this would be around 1 month of your fee. Or suppose you are doing your consultancy and suppose you get a project, steel design project, after doing this program, it would be, let's say, your consultancy fee for 1 or 2 projects. So such quick return on investments you will get. And of course, the hardcore structural engineering knowledge, which is priceless, that is of course the return that you get. What is the program outcome? Of course, this is very important to understand, because you are spending so much time and money and devoting devoting so much effort, it is quite understandable to know what will be the outcome. So you will develop confidence of working on actual structural steel projects. You will understand the steps involved in a structural engineering project, right from the planning to final BOQ and calculation preparation. As a participant, you will become comfortable with the relevant Indian standards. We would be going through several Indian standards in this program, as and when whatever is required, seismic code or wind code or steel design code, whatever is required, we would be going through. And of course, you will gain the necessary skills to work either as a structural engineer or as a structural consultant in the due course. Now, how to proceed ahead? So after today's session, we will give you a response form. You can indicate whether or not you want to join. If you want to join, you can get in touch with us. Do not pay anything without getting in touch with us. Okay, so get in touch. We would like to talk to you, and then you can join. You may pay the fee either as lump sum or in the form of first installment, and whatever discounts are applicable, proportionately you need to pay. And once you do these formalities, we will be admitting to you to a separate WhatsApp group for this program, where we will be sharing you the daily links and other details. When do we start? We start on 4th of July. 4th of July, Independence Day for America. So we start on 4th of July, Monday at 8:30 a.m. Even if you do not wish to attend, you can continue to remain on the WhatsApp group that we have created. We can stay in touch. We can be in contact. Okay, we are introducing an accelerated option also. What does this accelerated option means? Suppose, as I told you, we would be starting on 4th of July. That is still around 10 days or 12 days from today. Suppose you are quite clear, if you are quite certain that you want to join this program, you may not wait till 4th of July. You can join this program as soon as possible. And what you can do is that we will give you access to the 2 online courses, which will form the theoretical base for you. So till the time we actually start on 4th of July, you can go through some of these sessions, which will actually form some basic level understanding for you. All right. So you will be in a way warmed up before we start our actual projects on 4th of July. So if you have decided that you will join, no need to wait till 4th of July. Join as soon as possible. We will give you access to the 2 online courses, so that in the intervening 11 to 12 days, you watch some sessions of this course and you get acquainted yourself with the basics of steel design. That will actually help you when we start doing our projects. All right. Right. So I think that's all what I had to tell you. It took almost 1 hour to finish all these things. So thank you for patiently listening. And now we will have queries from your side. One important thing I would like to tell you over here, that all the projects, this may seem to be slightly odd, but all the projects we will be doing till the base plate level only. Okay. Base plate level means we will not be doing the RCC designs. That means generally in steel structures, we will have some foundation system also. So we are not going to do foundation system. We will only be doing all these projects till the base plate level. There's a reason why we are not doing RCC designs, because then it will involve a lot of other things that you should understand and that would be required. So we will be doing till base plate level. I may introduce the concepts needed to do the footing systems, but we are not going to do footing systems in this program. Okay. This is to ensure that we focus, our entire focus is on the steel projects, and we do not basically spend time in RCC footing designs. For footing design, I will give you some briefs, but we will not be doing footing design as such. All right. So all our designs, all our projects that we are going to do, they will end at the base plate level. So this is one important point that I wanted to clarify. Yes. So I think this is what I had to tell you. Now, if there are any queries, you may ask. Kashaf is saying, then how come it will be a complete project? Yeah, I understand it will not be, you can say in a way it's not a complete project, but you should understand that when you are doing, let's say, if you are working as a pre-engineered, if you are working in a pre-engineered company, they will only give you the design till the base plate. And then someone else is required to do the foundation system design. Okay. So if we do the foundation design also, you will understand that there can be several systems of foundation that you might have to use. So then we lose our focus. Our focus in this program is to learn steel design by working on actual steel projects. So to maintain our focus, we will be doing till the base plate level. If you want to know more about footing design, you can contact separately. I will tell you, or in the program also, I'll give you a brief introduction, but we will not be doing the detailed level design of substructural systems. Okay. Yes. Kirti is asking, she wants to join the RCC design course. How can I get details? You can send a message to us on WhatsApp. We will guide you further over there. Right. Hiren is asking, could you also give access to your third program? Third program means, which is the third program you're talking about? I'm not quite sure which third program you're talking about. Okay, anything else? I'll just check on YouTube if we have any questions, because some of you are watching this session on YouTube. So let me just go to the YouTube link and see if there is any question over there. Yes, any other question, if you could, you want to ask, can type. Hiren, if you could clarify, what do you mean by third program? He's saying you have mentioned 3 courses conducted. No, we related to steel designs, we have conducted 2 important courses. One was the comprehensive design and detailing of steel structures, that we are including as a part of this program. And another course was a course on PEB designs. So that will be included as a part of this program. So 2 online courses will be a part of this program. They will help you to get a theoretical base. All right. Right. Yes. Anything else? Yes. So there was a question related to, can this course be taken as self-paced learning course because of people being working professionals? So we have already discussed that for working professionals, they can take this course as self-paced learning. And yeah, so I think these are the questions we have. All right. Anything else anyone wants to ask? Okay, so that's all we have for today. We would be starting this from 4th of July. As I told you, if you want to join, do not wait till 4th of July. You can join ASAP, and you can start with the online course on steel design so that you understand basics of steel design. That will actually help you when we start with our projects on 4th. We would be directly starting with the project. So we would be starting on 4th of July with our first project. That will be the pedestrian footover bridge. So that's all we have for today. Thank you. And if you have any further queries, questions, doubts, difficulties, you can contact us on phone or on WhatsApp or through emails or on the WhatsApp group, whichever medium you find comfortable. Thank you. That's all. We hope to see all of you on 4th of July when we start our program. Bye bye.